Welcome, my dear students. First semester. This is day 11. This is our session, our virtual session for today. So let's get started. We are going to study today the greatest common factor. Okay, so what is the greatest common factor? Okay, I have a definition here that I would like you to copy in your notebooks. Definition is the largest number that is a common factor of two or more numbers. Okay, that is the largest number that can divide two or more numbers. Okay, for example, let's see. First example, you have 18, 12, and 6. Okay, let's solve it. Well, this method, maybe you learn another method. Well, if you feel comfortable with your method, you can use it. But what I do is that I draw a line here, and I have 18, 12, and 6, and I start finding the numbers, the prime numbers, the prime factors that can of these numbers. For example, they are all factors of 2. Okay, 2 is a prime number that can divide 18, 12, and 6 at the same time. Okay, so I divide them. 18 divided by 2 is 9. 12 divided by 2 is 6. And 6 divided by 2 is 3. Okay, now I have 9, 6, and 3. Now I have to find the next prime number that can divide these three numbers at the same time. Okay, 6 can be divided by 2, but 9 and 3 cannot be divided by 2. So I have to discard 2. But I see that 9, 6, and 3 can be divided by 3. It's a prime number, so I write 3. And I divide 9, 6, and 3 by 3. So 9 divided by 3 is 3. 6 divided by 3 is 2, and 3 divided by 3 is 1. Okay, now I have 3, 2, and 1. Okay, 3 can be, of course, be divided by 3, 2, but not 2. 2 can only be divided by 2 or 1. And 1, of course, can be divided by just itself, 1. Okay, so because I cannot find a prime number that can divide all these three numbers at the same time, okay, I am done finding those prime factors. I just have 2 and 3, 2 and 3. So my greatest common factor of these three numbers, 18, 12, and 6, is the product of those numbers. Sorry, it's 2 and 3. So I multiply and I find 6. So 6, the greatest common factor of 18, 12, and 6 is 6. Okay, we already said that the greatest common factor is the greatest number that can divide, in this case, 18, 12, and 6 at the same time. So the greatest common factor is 6. That means that 6 is the largest number that can divide 18, 12, and 6 at the same time. Okay, that's the answer, 6. Okay, let's work with another example. 20, 90, and 70. Okay, so again, I draw my line here, and I start finding those prime factors, those prime numbers that can divide 20, 90, and 70 at the same time. Okay, so I can see that they are even numbers. That means that they can be divided by 2. So I divide 20 by 2, it's 10. 90 by 2 is 45. And 70 by 2 is 35. Okay, 10 can still be divided by 2, but 45 and 35 cannot. Okay, so I have to stop using 2. Okay, now, but 3 can divide 45, but it cannot divide 10 and 35, so I cannot use 3. So I move to the next prime number. It's 5, and 5 can divide 10, 5 can divide 45, and 5 can divide 35. So that is the number that I have to use, because it can divide these three numbers, 10, 45, and 35 at the same time. So I divide 10 by 5, it's 2. I divide 45 by 5, it's 9. And I divide 35 by 5, which is 7. Okay, so I have 2, 9, and 7. 2 can be divided by 2. but 9 cannot. Okay, and neither 7. Okay, and 9 can be divided by 3, but not 7. 7 can be divided only by 7. It's a prime number, but I cannot divide 9 by 7. So I'm finished. Those 2 and 5 are the only numbers that I can use, 2 and 5. So the greatest common factor of 20, 90, and 70 is the product of 2 and 5. So 2 and 5 is 10. That's the answer. That's the greatest common factor. That's the largest number that can divide 20, 90, and 70 at the same time. Okay. So let's work with last example. Okay. This one. It's 48, 72, and 84. Again, draw my line. Okay, like this. 48, 72, and 84 are even numbers. They can be divided by 2. So I divide them by 2. 48 divided by 2 is 24. 72 divided by 2 is 36. 84 divided by 2 is 42. I have 24, 36, and 42. They are even numbers. They can still be divided by 2. Okay, so I do that. I divide 24 by 2. It's 12. I divide 36 by 2, it's 18. I divide 42 by 2, it's 21. Okay, I have 12, 18, and 21. 12 and 18 can still be divided by 2, but 21 cannot. Okay, so I stop using 2. But I can see that 12, 18, and 21 can be divided by 3, the next prime number. So that's what I'm going to do. I'm going to divide them by 3. So 12 divided by 3 is 4. 18 divided by 3 is 6. 21 divided by 3 is 7. Okay, I have 4, 6, and 7, and I cannot find a prime number that can divide 4, 6, and 7 at the same time. So that's it. I finished. The greatest common factor is 2 times 2 times 3, or 2 squared times 3, or in other words, it's 12. That is the greatest common factor, and again that means that 12 is the largest number that can divide 48, 72, and 84 at the same time. Okay, that's what it means. Okay, moving on, we have the next slide, this one, exercises for you to work on your notebooks, okay, your notes. Okay, so you can pause the video and start working with them, with all 14 of these exercises. Okay, and we can check them tomorrow. And the next slide, okay, this one. This slide is your home enjoyment. Okay. So we are going to check your home enjoyment tomorrow. Okay, so this is what you have to do. You have to find the greatest common factor that we just did of these 14 exercises in your notebooks, your notes, and your home enjoyment in your notebook for your home enjoyment. Okay, so I guess that's it. See you tomorrow.